So this page we're going to talk about some more information about algebraic factoring. What is a factor? Things like that. Factoring is a concept that many algebra students struggle with. So there are some things that we're going to do that are going to require factoring. So when we get to it, I'll review it one more time. So expect that I will review those topics. Let's take a look at our first one here, the greatest common factor of two monomials. When you think of greatest common factor, you are thinking of the largest thing that will divide into both. Okay, so think about that again. The largest value that you can divide into both. So what they will include is the lowest power from your variable. But the numbers, you might have to do a little bit of thinking. This one is 3 times 3. This one is 3 times 4. So what do they have in common? What do we have that they can both be divided by? 3. What W can they both be divided by? You have to choose the smallest value. So if you think about the fact, both of them can be divided by 3. Both of them can be divided by W third. Now, we're not talking about what they can divide into. That is a greatest common multiple, or sometimes least common multiple. We are talking about what is something, a factor is something that will divide into you evenly. A factor divides into you evenly. Does everybody see why the answer is 3W cubed? Okay. What will go into them? Both. Okay. So if we want to find the greatest common factor of different terms like this, think about the prime numbers that are in there. So first let's deal with the numbers. Do they all contain a 5? No. Nope. Do they all contain a 3? No. Nope. Do they all contain a 7? No. Nope. So the greatest common factor is only 1. Now, if they all contained a 5 or they all contained a 3, we'd include those things, but they just don't. So that's why I like kind of breaking them apart. I like thinking of 15 as 5 times 3. And then the common factor for the V's would only be if they all had V's, and it would be the lowest power. They don't even have that. It's actually V to the 0 if you want to think about it like that. So 1 is the greatest common factor, the only common factor, the only thing that will divide into all of them. So that was kind of a trick question in a way, but okay. Now let's talk about some algebraic type of factoring. You might recall from back in the day, I'm going to write this just a little different, and it might help you, okay? I'm going to call this X. This whole thing's going to be X. So if I wrote it as 3x minus 5wx, I think you get a sense that they both contain an X. This term contains an X. This term contains an X. So algebraically, I can factor out the X's, leaving everything else. That is exactly what happens here. So now let me go back to what was originally on the page. They both contain this stuff. So I can take that stuff out. And when I take that stuff out, I am left with a 3 for the first one and a negative 5w for the second one. See how this came out, this was left. Does that make sense how that one works? There's a technique that some teachers use called grouping for a factoring technique. This is like one of the last steps of grouping. So if you remember anything about grouping, that's kind of, I think, what they're trying to get you ready for, okay? So if you have a parenthesis, you are allowed to take that out as long as both pieces are touching the parenthesis, which this one was, okay? Let's look at this factoring. There are so many techniques of factorization. if you like one that your Algebra 1 or Algebra 2 teacher taught you, and it's working for you, go for it. Do it. Do your thing. If it's not working for you, listen to me. I'll teach you. Okay? Now, if this is just a plain old x squared, y squared, z squared, so if the coefficient on your highest power is a 1, all you got to do is look at the back number. And if the back number is positive, we're going to add to get the middle number. If the back number is negative, we're going to subtract to get the middle number. So what we're looking for is what two things will multiply to give us 20, but has a difference, because we're going to subtract, of 1. So tell me, what two things multiply to give us 20, but have a difference of 1? Yes?
Negative 5 and positive 4.
That is wonderful. And you'll notice that they got the signs right. That's perfect. Negative 5 and positive 4 multiply to give us negative 20, but have a difference of 1. Now, the reason you want to put the negative on the 5, this is what I always tell my students to remember. If the back is positive, they got to subtract. And just look to the middle. That middle has to be on the bigger one for it to get you what you want. And so you'll notice 5 is bigger than 4. Put that negative on the littler one. Okay? How can you check? Yesterday we did ones where we FOILed, where we distributed. If you distribute, you better get what you started with or something's wrong. Okay? Any questions on that factoring? I will tell you that factoring will come up again. When it comes up again, I will review it again. I always review algebra topics as if you might have forgotten them, just for future reference. You know, if you have a question, I'm gonna review it. Okay. Now, here is one that you have a front number. You have that 5 on RU squared. Here's what you look for. If that 5 is divisible in every single term, we get to take it out. So that's awesome when that happens. So in this particular one, every single thing is divisible by 5. So let's divide every term by 5. So we are allowed to factor out a greatest common factor. Okay, so let's do that first. So all of these pieces you're going to divide by 5. Here is the kicker. Everybody look. Do you see how this right here says factor completely? When it says factor completely, that means that you might have to break this apart one more time. Now, sometimes this part is what's called prime. You can't break it down further, but if they say the words factor completely, you may have to try it again. And that's one of these examples. We are going to need to break it down again. Using, just like we did 20 in the last one, what are the factors of 14 that have a difference of 5? What you got? You got it. Now let me write it down, and then I want you to tell us a little bit of something. So you said positive 7 and negative 2. Perfect. Why did you put the positive on the 7 and not the 2? You're perfect. Exactly. You put the positive on the bigger one if that positive is in that middle. Otherwise, you're going to get that negative. So always be mindful. If the back is negative, you're going to get a plus minus. The middle will tell you where to put the bigger sign. So here I have to put the bigger number gets the plus. Okay. Any questions on that factoring? Everybody caught up so far? Okay. Last one, and then you're ready to turn this in. So this one, no front numbers yet. We'll get to the ones where there's a front number that you have to do that, you know, you have to do a little bit of trickery to get it to work. If the back number is positive, we're always adding to the center. The back number here is a positive 64. So we're going to add the two things to get us the 16. What two factors make 64 when we multiply them, but add up to 16? What do you got?
y plus 8.
So you can write it two different ways. Feel free to write y plus 8 and y plus 8, be done with it. That's fine. Because those are matching factors, feel free if you want to write a little shortcut. You'll notice here they said a perfect square trinomial. That just means these two things will end up matching like they did. Okay? So now you should have finished these notes. So at this time, could you please upload this into Google Classroom? Okay, so let's do number 11 together. My suggestion for number 11 is you're going to want to do that square that's on the bottom first. Everything in the parentheses gets squared. So that's going to be 8x cubed over 4x squared. Now when I do an algebraic fraction like this, what I like to do is I like to treat the numbers, if it was a fraction, what would I do? And then treat the variables kind of as its own unique thing. So I kind of separate it in my head. 8 divided by 4 is 2. But because there's other stuff down there, sometimes I'll just put a little 1 placeholder so as a just in case. The x squared and the x cubed, technically if you think about the rules of exponents, says if the bases are like and we're dividing, you keep the base and you subtract the exponent. So 3 minus 2 is 1. The x to the first is up at the top because we have an extra x in the numerator, not the denominator. This just one happened that everything of any importance in our denominator canceled out. So I would probably go until it just read 2x. You could write 2x over 1. I'm not worried about that. If you left it like that, you're still correct. And I'll mention to you, hey, you should probably write it a little differently or whatever. Did that help you with that one? Do we have any other questions about the ones that we talked about from yesterday? Yes? 16. Okay, so radicals. Let's talk about those. So I'm glad you asked about those. In the actual, like the review paper that we did, there wasn't much about radicals at all. So many of the radical ones I'll do with you now because you haven't had a chance to see those things. First, let's talk about the top of our fraction because it is a radical that can reduce. Do you guys remember, anybody off the top of their head, what the square root of 121 is? Yeah.
11.
It's 11, okay? So what we're going to do first off is reduce that top as much as possible. And then if you could, write the bottom in parentheses. Now you may recall from back in algebra, radicals should not be left in our denominators. So if it just said radical b on the bottom, great thing that you can do is multiply by radical b on top and bottom and it will fix the problem. But this does not say that. It says 1 plus radical b in the bottom. So what you're going to do is use something called the conjugate. Okay, we're going to use something called the conjugate. The conjugate of 1 plus the square root of b, it's that difference of squares formula technically, is 1 minus the square root of b. So put that in parentheses on the top and the bottom. Now, what that's going to do is that is going to allow us to no longer have radicals in our denominator. That's your main goal. For the top, we'll use the distributive property. 11b times 1 is 11b. 11b times a radical, just throw that 11b in front of the radical. Now let's talk about the bottom. Remember, a plus b times a minus b is always the difference of squares. So if you see a difference of squares, you can always apply that formula. So in our case, the a is 1, the b is the square root of b. So we have to square those things. If I square a 1, I get a 1. If I square a square root, I get the thing inside, so I get a b. I can't go further with that. I cannot cancel out a 1 minus b unless it has a perfectly matched factor in parentheses of a 1 minus b. So don't try to just start crossing out b's and doing something funky. You can't. So that is your answer. You're done. Now if you left it like top in parentheses, bottom in parentheses, that works too. But that's about as far as you can go. It's a yucky kind of problem. Okay. Any of the other radical ones at this time? Now tomorrow I will take more questions. I kind of want you to jump in and try what you want. But are there any other radical ones for now that you look at and go, hey, Mrs. Hott, I forget how to do blank? Any other ones you want to talk about right now? Do you have a question? Anybody? Yes.
18.
18. So let's talk about when that little index is there. So this number here is called an index. Those are indices, index. The index just tells me what type of radical I'm going to use. So if it's a 3 there, I have to look for perfect cubes. What are perfect cubes? 2 cubed is 8, 3 cubed is 27, 4 cubed is 64. They're very specific numbers I'm searching for. Same thing for 4. 2 to the 4th is 16. 3 to the 4th is 81. 4 to the 4th is 256. 5 to the 4th, guess what? 625. So the top one here is interesting. If you have a index that's odd, like a 3, a negative stays a negative. A negative inside of a even one, like a square root, has some issues. You guys know that probably. But that works because negative 2 times negative 2 times negative 2 is negative 8. Perfect. 625, that's 5 times 5 times 5 times 5, so that's just 5. So this was negative 2 times negative 2 times negative 2. Negative 2 over 5, once we pop them out of their radical, only if the fraction reduces do you have to worry about it. Otherwise, that's it. You're kind of stuck. That's your answer. Any other ones right now that you would like to look at? Okay. So we will, I will take more questions at any time. You just got to ask. But I'm going to post this on YouTube.